Okay, students, are you able to see the slide? Okay. So we have to discuss now about the dual of Miller's theorem. This diagram already I have drawn in last class, and here so let V1 is input voltage of a two-port network, and in this figure let V2 is output voltage of a two-port network, right? And let Z is the impedance. Impedance connected to input and output ports, right? So now since Z is connected to input and output port here, this is ground here in Z, right? So this Z will affect both input and output side, both input and output, right? So now use of dual of Miller's theorem, right? So this dual of Miller theorem is used to break this Z in two parts, right? It is used to break Z into two parts, right? So it is used to break the Z into two parts, and one part will be connected to the input circuit and other will be connected to the output circuit. Two part, one part of Z will be connected to input circuit and other part to output circuit. Right? So in this way we will get this type of circuit. Here we have Z1 and here we have Z2. From the part from means the section where it was connected with input and output both, from there we have removed this Z now, right? And we have broken this Z in two parts, that is Z1 and Z2. In this section, in this port, the voltage is V1 and current is I1. And in this part of the port, current is I2 and this Z is Z2. And here we have the voltage V2. Right? So this is our figure 2. Right? So by using the dual of Miller's theorem, we have broken the Z into two parts. One part we have connected to the input side, and that is your Z1, and another is in the output side, that is your Z2. Right? Now apply. See, in Miller's theorem we applied the Kirchhoff's current law, but here we will apply the Kirchhoff's voltage law. Right? So apply Kirchhoff's voltage law at input circuit. Of figure 1, right? So we will apply the KVL at input side of figure 1. So this is a figure 1, right? So here you can see in the input side, this is the input side. If you apply KVL, then if we move in this way, in clockwise direction, then it will be V1 minus Z into this current I1 plus I2 is equal to 0. V1 minus I1 plus I2 Z is equal to 0. Or we will transfer the second term toward the right side. So V1 is equal to I1 plus I2, right? So I2 Z. So we call this as our equation number 1. Now we apply Kirchhoff's voltage law at output side, at output circuit. Of figure 1, right? So we see here, this is figure 1. So in the output circuit, in this way, if we move, then we apply the Kirchhoff's voltage law, then it will be V2 and the voltage across this Z. So it will be minus Z into I1 plus I2. So it will be V2 minus I1 plus I2 Z is equal to 0. Or the second term we will transfer to the right side. So we will get V2 is equal to I1 plus I2 Z, and we call this as our equation number 2. Right? Now what we will do? Now we will come to the figure 2. So now apply Kirchhoff's voltage law at input circuit of figure 2. You come to this figure 2. So here in this we will move like this and we will apply the Kirchhoff's voltage law. So it will be V1 minus I1 Z1 is equal to 0. So we will get V1 minus I1 Z1 is equal to 0, right? Or we will shift the second terms toward the right side. So we will get V1 is equal to I1 Z1, and we give this expression number 3, right? And now we apply Kirchhoff's voltage law at output circuit of figure 2, right? So we see this figure 2. Okay, we move like this and we apply Kirchhoff's voltage law. So it will be V2 minus I2 Z2 is equal to 0. So it will be V2 minus I2 Z2 is equal to 0, or we shift the second term toward the right side. So we will get V2 is equal to I2 Z2, right? And this will be my equation number 4, right? So we have two figures. In each figure, we will apply two KVLs, one at the input side, one at the output side, right? And by this, we will get four equations, right? We will get 4 equations. Now, our aim here is to find out. Our aim here is to find out the value of this Z1, right? To find out the value of this Z1, right? Because earlier there was Z. In actual there is a circuit like this. There is a impedance Z which is connected common to the input and output port now. And we have split it into two parts, Z1 and Z2. So if we are able to find out the value of Z1 and Z2, then we can replace Z1 and Z2 by those values simply, right? So for that, you just see here equation number 1 and equation number 3. 1 and 3. So in 3, we are having the value of V1. This we will put in equation 1, right? So putting the value of V1 from 3 into 1 right? So what we get, V1 is I1 Z1. So here we will put, okay. So it will be I1 Z1 is equal to I1 plus I2 into Z, right? We got this. Now we will bring this equation in terms of Z1, right? We will bring this equation in terms of Z1. So Z1 is equal to I1 plus I2 Z by I1. Or this equation we can write it as, in numerator this I1 and denominator I1, this we will cancel out. So we will get here 1 plus I2 by I1 Z, right? We have come to this equation. Now here, this figure, you just see this figure at the output section. If we connect load here, some load, right? Let us assume RL, right? So here you are having the current IL. Here you are having the current IL, right? So this IL, and if you write the current gain, so current gain you can write it as IL by I1, right? Or you can write it as minus I2 by I1, because IL and I2, right, both are same in opposite direction. Okay, this. Okay. So with this we will move. So I remove here from here. So see, I'll write here. Since AI is equal to minus I2 by I1, right? So we can write this Z1 is equal to 1 minus AI Z, right? 1 minus AI Z, and this is our equation. This is our equation number 5. Now same way you, हाँ जी, हाँ है, already sent. Already I sent. Okay. Okay, I will complete the class, then I will send. So you see now equation 2 and equation 4, right? In equation 2 and equation 4. So from 4 V2 value we will put in equation 2, right? So here putting the value of V2 from 4 into 2, right? So V2 is I2Z2. Okay. So I2 is equal to I1 plus I2 Z. And now we will bring this equation in terms of Z2. So this will be I1 plus I2 Z by I2, right? So with this we will get Z2 is Z2 is equal to yes, yes, I am not getting you are here only. So well, again we have to forward. Yes. Okay, after class I will re-forward or okay. Okay, so we will get I1 by I2 plus 1. I1 by I2 plus 1 Z, right? Right. So this we can write it as this is equal to 1 by AI plus 1 Z, right? So this will be our equation number 5. 5 or 6? 6. Right, from here we will get the values of Z1 and Z2. So if we have Z connected in that way, then we can remove that Z into two parts, Z1 and Z2, and we can calculate the values by this, right? So equation 5 and 6, where we are getting the values on Z1 and Z2, are dual of Miller's theorem. Okay. So with this, we have completed the unit 3rd. Now from next class, we will start the last unit. Okay.